So in this video, I'm going over the determinant notation and the inverse, but also making sure just little things here and there on your notation when using like Desmos, the matrix calculator. So like here, notice I'll just kind of do like a side by side, but go ahead and I've already put the two matrices here in the calculator, but same thing. You guys go ahead, right? Pause the video, put the two matrices in the Desmos matrix calculator, and go ahead and see what is D times G, or in this case, A times B. Then flip it, and then see what you notice. And here we go. So I'm going to go ahead now and show. So what is A times B? Well, notice we've got like this 1, 0, 0, 1 situation here, right? Now let's flip it. B times A. Oh, what do you notice? This whole concept of this 1, 0, 0, 1. What this means is when you end up with a matrix that here, when you have them being multiplied together, that means the two matrices are what are called inverses of each other. So A is the inverse of B, and B is the inverse of A. And then again, I'll show you guys how you can see that in Desmos calculator. So here, now, to know though, if a matrix even has an inverse, we can calculate what's called the determinant, right? So remember, the determinant is going to just let us know if there is an inverse. Now, notice the notation here. This notation is for what you'll see in Desmos, which we'll be getting to in a bit, but this is the notation. It's like with the absolute value bars. So notice with the absolute value, that shows the determinant. So basically notice here, to calculate the determinant by hand, it's like a crisscross. We're going to do A times D. We're going to do A times D minus B times C. Now, if the determinant is not 0, then the matrix has an inverse. We could have a positive, we could have a negative, but you cannot have 0. If we end up with 0, then the matrix does not have an inverse. So like here, for example, we're going to see how the notation with the absolute value. So that means we're going to calculate the determinant. So that means here we're going to multiply 2 times 0, which is 0, minus 3 times -1, which is -3. So notice here I got a value of 3. That's my determinant. So is this matrix invertible? Yes, because of the determinant of 3. So then here, again, this absolute value doesn't mean absolute value. This represents the determinant. So again, multiply. 3 times 2 is 6, minus, again here, which is also 6. Oh, notice this is 0. So is there an inverse for this matrix? No, because we got a determinant of 0. Now notice with 1C, we always have to do a cross multiply. So think about like it's got to be a square matrix. But can we do that here with our matrix? No. So then automatically there's no determinant, no inverse. Go ahead and try these two on your own. And here we go. 1 times 5 is 5, minus 3 times 2 is 6. -1 is the determinant. So yes, there is an inverse here. Then here I've got 15 minus -3, which makes my determinant 18. So yes, there is an inverse to this matrix. So remember, the determinant, if it's 0, there is no matrix. And then a couple other things too, like what we just said. The matrix must be a square matrix. So like, for example, right, it's got to be like a 2 by 2 or 3 by 3. So then here, now, if I want to get the inverse, so here, now I'm going to show you on the Desmos matrix calculator here. Notice now, so remember, right, determinant is with the absolute value symbol like that. So that's the determinant. If we want the inverse of a matrix, you're going to see this notation here, like an A to the -1 power. That's the notation for the inverse. So let's say here, I want to know what is the inverse of this matrix. So if this, let's say, is matrix A, I want to know what is the inverse. You would see this notation. So basically here, if you notice, let's say I've got my A here already set. So how about this? I'll go ahead and change this A here. So A is 4, -2, -1, and 3, right? So now here, let me delete these because I just changed my matrix. Now, we want the inverse. Don't just press look. See how it says the A to the -1? But I want the inverse of A. So A, then -1. And there it is. That is the inverse matrix. So here we're at 0.3, 0.2, 0.1, and 0.4. So notice with the matrices, it's about that notation. So same thing here. If I want the inverse, so then that just means you have your values here and then press A and then inverse button. So here, try this one, the 5, 7, 2, 3. Get the inverse. And here we go. So I'll go ahead and even delete this here. I'll even delete this one here. Ooh, all right. So here we go. I've got 5, 7, 2, and 3, right? So here we go. That means to get the inverse of this matrix, I have to first use my A because that's my matrix label, and then -1. And there it is. That is our inverse. So the inverse here is 3, -7, -2, and 5. That is the inverse. Now, what if I wanted to know what was the determinant, right? We would do 5 times 3, which is 15, minus 14, which is 1. Now again, notice, also here, DET. So if I wanted to know what was the determinant of my matrix, you press that determinant and then also the matrix label that we're looking for. So let's say A, and there it is, my value of 1. So same thing. Even if you wanted to do a 3 by 3, you can use Desmos calculator here and get that information. So what I'll do is in the video, make sure that you're good to go with the notation. So I'll give you the chance to get your calculator set up. I'll go over these questions to make sure you're good to go with all of our notation here. And here we go. So notice, what does this mean? The determinant. So you needed to find the determinant of A. So that means here, I'm going to find the determinant of A. And that is equal to, that is equal to 4. Now notice, what does number 6 notation mean? The inverse of R, which in this case is my B. So I want the inverse of B, and there it is. So the inverse is -2.5 to 1.5, -1. Then here, this is our notation. So make sure you're good to go, right? So I want matrix R. What does that first number represent? Your row, right? And then column. So what element in matrix R is in the first row, second column? Boom, right here, that value of 4. So then here in A, again, second row, first column. So second row, first column. That element is -2. So then here, notice with your operations, you had to find 2 times A plus R. So again, remember, right, I used B here. So that is 2 times A plus B in my case, because that was my R. And there it is. So this here is 8, 2, -1, 9. So notice, right, because that's scalar multiplication, 2 times A and plus the matrix R. And here, notice we are multiplying. Now, notice that we got flipped, right? So this is not A times R, this is R times A. So this is B times A. And that is your matrix, which here is -2, 6 and -1, 7.